Dr. Senthil Madasamy, Associate Professor, Computer Science and Engineering. Welcome to this session on Static Analysis Tools for one credit course DEVOPS Technologies. In this session, topic to be covered is Static Analysis Tools under Model 3, Continuous Integration and Continuous Deployment. At the end of Model 3, students will be able to automate IT infrastructure. At the end of this session, the students will be able to describe the introduction about static code analysis tools. We will see what is static code analysis, why of static code analysis, benefits of static code analysis, static analysis versus dynamic analysis, available static code analysis tools, and summary of session. Now we look at what is static code analysis. Code analysis is not a new thing. Code analysis was in the software industry for a long time. Senior developers or team lead had responsibility to set up manual code analysis to maintain the quality of source code of the software. Static code analysis is a method of computer program debugging that is done by examining the code without executing the program. Static code analysis, also commonly called white box testing. Source code is available to the testers, including many types of testing methods. The process provides an understanding of the code structure and can help to ensure that the code adheres to industry standards. This method of security testing has distinct advantages in that it can evaluate both web and non-web applications, and through advanced modeling can detect the flaws in the software inputs and the outputs that cannot be seen through dynamic web scanning alone. From last few years, software code quality and security has gone from being a nice to have to necessity, and many organizations static code analysis scan all code. Static analysis has a higher probability of finding those vulnerabilities. Static code analysis is a method of detecting errors and defects located in the source code of a program without execution. Static code analyzer looks for patterns defined to them as rules, which it can pass those security, vulnerability, or other code quality problems necessary for production quality code. Static code analyzers are not a new thing, and they are here from long time. But as a senior Java developer or team lead, you have a responsibility to set up process like automated code analysis, continuous integration, automated testing to keep your project in healthy state and promote best development practices in your team. Static code analysis saves precious remediation time. Unique best fix location algorithm fixes multiple vulnerabilities at a single point. Any developer can do it. Tons of time saved for developers. Benefits of static code analysis is effortless scan is ease of use. No complex command line or wizards required. No dependencies need to be configured. No learning curve when switching between languages. Just throw the code at it. Static code analysis tool do scan at source code but not at binary code. Another benefit is fast feedback loop. Incremental scan capability only analyze new code or modified code. Reduces the scanning time by more than 80%. It is ideal for continuous integration. Another benefit is provable results. Provides reasoning and proof with all results. Shows the underlying scan rule to provide root cause. Flexible rules provides high accuracy. Adapt a rule set to your proprietary code and minimize false positives. Expand the rules to your own compliance requirements and coding best practices. Understand the root cause for each result. The static code analysis tools are SonarQube, CodeSonar, Q1, JSLint, Veracode, FindBugs, and PV Studio. Most of the developers are using SonarQube. Both types of analysis, static and dynamic analysis, detect flaws. The big difference is where they find flaws in the development lifecycle. Static analysis identifies the flaws before you run a program. Example between coding and unit testing. Dynamic analysis identifies the flaws after you run a program during the unit testing. However, some coding errors might not be detected during the unit testing. So there are the flaws that dynamic testing might miss it. But static code analysis can find. Advantages of static code analysis are it can find weaknesses in the code at the exact location. It can be found by trained software assurance developers who fully understand the code. It allows a quicker turnaround for success. It is relatively fast if automated tools are used. Automated tools can scan the entire code base. Automated tools can provide mitigation recommendations, reducing the research time. It permits weaknesses to be found earlier in the development lifecycle. That's why reducing the cost to fix. Few limitations of static code analysis are it is time consuming if conducted manually. Automated tools do not support all programming languages. Automated tools produce false positives and false negatives. It does not find vulnerabilities introduced in the runtime environment. In this session, I summarized the introduction and use of static code analysis tool and listed the different static analysis tools. I hope you found this session is more informative. Second part of this topic under Module 3 will cover SonarQube installation in next video lecture. Thank you and have a great day.